Hi guys, welcome to chapter 13, Genetic Change Through Selection. A little bit of a challenging chapter. It'll be new for some of you. We'll move away from Punnett squares and that stuff you were studying when you were in high school. And we're going to talk a little bit more about phenotypes and genotypes. So this is just an interesting slide that kind of shows you how vast genetic variation can be. So if an animal only had one pair of heterozygous genes, like we talked about coat color in cattle, big B versus little b would be this example. So you could have a sperm that had, or an egg that had a big B or a little b. So there would be two genetically different sperm or eggs. And there would be three possible combinations of genotypes you could get. We already studied that. Big B, big B, little b, heterozygous, or little b. So that's easy when we're only looking at one pair of genes. When we get to two pairs, it gets more complicated. And when we get to an animal that is more realistic, what it shows you is that the genetic variation in livestock is, I don't want to say it's unlimited, but it's pretty vast. So that's the point of this slide. This slide is really interesting, and it doesn't matter whether we're talking about breeding dogs or breeding cattle. Since it's an animal science class more oriented towards farm animals, I'll give you an example based off of cattle. So elite seed stock producers are people that utilize a great degree of technology to produce high-end livestock. A good example of this in our local area would be Vintage Angus. They have a sale every year of their females and of the males, and sorry about that. And they use a lot of embryo transfer, artificial insemination, but they are breeding the purebred Angus cattle at a very high level. And they will sell expensive bulls, embryos, and heifers and cows to multipliers. And then multipliers buy them and they produce like range bulls. That would be the best example. And range bulls are going to go out on the range and produce the calves that they're going to breed the commercial cows, which is, a non-registered cow. She's out on the range, out in Farmington or up in the foothills up outside of Oakdale. She's going to breed he's going to breed those cows, and he may be a registered Angus, and he's going to produce a high quality calf. And then that calf is going to go to a feedlot. So the elite seed stock is where genetics are very well documented. We know the genotypes of those animals as well as their phenotype. Multiplier, a little more, but not 100% as concerned about genetic traits as the elite seed stock producer. And then the commercial producer really just wants every cow to have a calf, a healthy calf that is going to have a good solid weaning weight. Okay, so that goes to the next slide. We talk about weaning weights. This could be a bell-shaped curve for your grades or for just about anything, but it gives you an idea of, when you have genetic variation, we always have, this is in weaning weights for calves. So we always have some extremes. We have the calves that wean at extremely low weights. Those, we need to take a serious look at because they're not going to make us very much money. And then we have these outliers that those are the ones, we want to look at those cows that produce those calves or the environmental situation those cows were under because their weaning weights are extremely high. So that bell-shaped curve kind of gives us the average weaning weight, but realize that there's a lot of variation in the average because of genetics. And this is just another bell-shaped curve that shows you that about 60%, 68% of weaned calves fall within this 400 to 480 span of this bell-shaped curve. And then as we look at other standards, we can, see what percent of that bell-shaped curve where the weaning weights are. But this is kind of gives us our average weaning weight. And obviously a producer wants to shift towards a heavier calf because when you sell your calves, you get paid by the pound. So a heavier calf means more money in your pocket. So when we look at the genetic model, it's really important that you understand these things. A little bit of review from last time. So the phenotype is what the animal looks like. Okay, that's the ultimate outcome. If you raised a lamb for your county fair or a pig or a steer, or you have a dog at home or a cat, the phenotype is what it looks like. The phenotype really comes about through two things, which we're going to focus on in this chapter. the genotype, which is the animal's genetics. If it's a breed of livestock, then its phenotype is kind of pre-described. Like Angus cattle are black. They're known for their good quality carcass traits. That is their phenotype. If we look at their genotype, that would be, looking at their pedigree, where their ancestors came from, and we look at what traits they have that are desirable. Okay, breeding value are the traits that can be passed on by selection. Non-additive value are genetic traits animal might have, but they're not necessarily going to be passed on to the next generation. So phenotype's what we look like, genotype's what our genes say. When we look at the environment has an impact on your phenotype, right? If you could be the best Angus bull in the world, but if you were with best genetics ever, but if you were born in the middle of a snowstorm in South Dakota and your mom only produced a minimal amount of milk, then you're not going to grow because she was sick, not because she was genetically inferior. You're not going to grow very well. So the environment plays a huge role. Nutrition, things like that, that's the environment. So the environment also creates the phenotype. As an ag teacher, I always used to like to say, you can go out and buy the best lamb you can afford. You pay $1,000 for a market lamb, but you don't feed it and you don't take care of it and you don't vaccinate it, its phenotype isn't going to be very good. So all of these factors, your environmental factors, are just as important as genotype. And that's kind of what the book talks a little bit about it. So there are known factors in the environment, for example, like how good the mother, if it's a sheep, how good the mother milks. Does she produce a lot of milk? Is she a good mama? She protects her babies. She calls to them when it's time to eat. All those types of things, those are known behavioral traits. Unknown environmental factors could be things like exposure to disease or parasites or something like that. So anyway, that's kind of an important slide. This is just a random slide that shows you genetic variation in the belted pattern in the Hampshire breed of hogs. So Hampshires are black. Some of these pigs are just terrible too. But the Hampshires are black, and one of the breed characteristics is that they have this white belting. And you can see from a tiny narrow belt to a wide belt, kind of a misshapen belt. That is a breed characteristic. And if the belt isn't properly placed on the hog, this white portion of hair, then the animal can actually be, disqualified from the breed. So some breed characteristics are phenotype, what the animal looks like. So a phenotype is just what I said. Phenotype is a physical property of an animal that can be observed or measured. Individuals have a vast number of potential phenotypes. Phenotypes can include color, like coat color in cattle. We talked about black and red. Can include birth weight, the weight at which they're weaned from their dam, their yearling weight, milk production, color, I already said that, and feed efficiency. So the genotype, remember, your genotype is what your genes say. So your genotype, remember, whether it's your calf at home or your dog or your cat or you as a human, your genotype comes from your parents. Half of your genes come from your dad and half of your genes come from your mom. So when we talk about the genotype, there's two sections of the genotype. The breeding value sections is most important because those are the traits, the genes that control things that we can select for, like milk production in cows or sheep. That has breeding value. Non-additive value are values that are not passed on. So, and it's a little bit complicated, but if you remember the heterozygote, the animal that is a crossbred, has a mixed pedigree, that a lot of times those genetic traits, it's very hard to select for those because we can't see the genes. We can do a DNA analysis, that's expensive and it takes time, but a lot of times that heterozygote or crossbred animal fits in this category. If you want to learn more about that, I suggest you look in depth in the book because it does give a good description. So breeding value responds to selection. That's what I just said. So breeding value is the part of the genotype that is passed from the parent to the offspring or progeny. So breeding value is determined by the effect of the genes and trying to improve it. So additive effect could be, like we said earlier, weaning weight or yearling weight. If we select from the sire and he has a high weaning weight genetically, and the dam has the same thing, those would be additive effects. So that would be important. A negative one would be maybe resistance to some disease, although that's genetically not very common. But that is very important to that top of that pyramid, that people that are producing those animals where the pedigree is extremely important and they want to pass down those high quality livestock to the next level of production. Non-additive value responds to crossbreeding. So it's the portion of the genotype determined by the way the genes are combined in the individual. It's unique to each individual and is typically not passed from generation to generation. And one of the things you have to remember about crossbred animals is crossbred animals, many times in the livestock world, crossbred animals are sometimes what we call a terminal product. So that means their destiny is not to reproduce, but to go into the market. So let me give you an example in sheep. You have the blackface mutton breeds of sheep like the Suffolk and the Hampshire. That is known as a meat breed, and that's kind of the sire breed. On the female side, you have the white-faced breeds, which are the wool breeds. And so in a commercial sheep operation, you cross the blackface meat mutton type sires onto white-faced ewes. The offspring is called a brockle face or a speck or a speckle, and they have black and white on their face. They're easy to identify. And those are a terminal product. Half of their genetics comes from the meat side and half comes from the wool side. We have to have those wool producers because that's part of our income in the sheep industry. But we want a terminal product that can go to market. So that idea of crossbreeding oftentimes leads to that terminal product. Definitely so in the meat industry for chickens, where we have the Cornish and the Plymouth Rock cross. So the animals that are crossbred oftentimes are not selected as breeders because we can't predict how their genetics are going to play out. Whereas a purebred animal that has a pedigree, we can do that. It's a little bit of a complicated concept. So let's talk about the environment. So the environment are non-genetic effects that influence the phenotype. So what an animal looks like. So we can have known factors that influence the environment, and we can have unknown or random effects, and those are the worst. So the known effects of the environment have an impact on a specific category a lot of time. So a lot of times, for example, in cattle or sheep, the season of birth will affect the weaning weight. So an animal that is born in a season where there's more grass available. So in cattle, we typically calve in the spring or in the fall. We don't calve year round because you want your calves to be weaned at one time and you want them all to be about the same weight. So if you choose to wean in the fall and we have a dry year, that's an environmental effect that can affect that calf's weaning weight because there's no grass for the cow to eat, therefore she doesn't make very much milk. So those are known effects. The other thing is the other known effects, for example, heifers, a lot of times they will produce a smaller calf because their body size is smaller. So environment is things that we can control that are known. Unknown effects, as you might imagine, could be an animal that gets sick. We can't predict we can vaccinate it and try to prevent disease, but we can't tell if that calf's going to get tangled up in a barbed wire fence, and that's definitely, he's going to be injured, he's not going to feel like eating, so that could affect his weaning weight. So the environment can impact in two ways. Things that we know, like specific things about the environment that calf or lamb was born into, and then unknown things like, did the dog, bite it or something like that. So that's a factor when it comes to animal selection. So this slide is one I put in here. I think I'm going to stop and I'm going to start the next slide presentation on this. And the next one shouldn't be too long. I'm going to go ahead and stop on this one so I can talk a little bit more about it in the next slide presentation. Okay, I'll see you in a little bit.